In topic 6, we're going to be looking at finding the distance and midpoint of a line. So there's two formulas we're going to be using. The first one is the distance of a line formula, or the distance formula, and you can see that right down here. So this is an explanation of how to derive the formula or how to get the formula, and I will explain that a little more in class, but let's just get to using it in this video. So example 1, we have 2 points A, and then there's the coordinates for A and B, and there's the coordinates for B. Find the distance between these 2 points. So it's like having 2 points on a graph, as we could see here, 1 and 2, and we are finding the distance in between them. So we are going to use the distance formula for that. Now you'll notice inside this formula we have x2, x1, y2, y1. So let's see what these things actually mean. So what we're going to do is we're going to take our 2 points, and I like to label them so I don't get confused. So this first set of coordinates is our number 1 coordinates. So 2 is our number 1 x value. So I'm going to put x, and then I'm going to put a 1 down there. So that's our x1. And then this 3 is going to be our y1. So if this is like our number 1 set of coordinates, we have x1 and y1. Next, we have the second set of coordinates, or our second point. So then this 6 is going to be our second x, or x2. And the y is going to be the y2. Now keep in mind, this is not the same as x squared or y squared. That is different. This is a superscript where it's up in the air, so that's like a power. But when we have it lower down here, that is called a subscript, and it's just a label for the letter, or a label for the variable. So it's just telling us that this is from our second coordinate, or the first coordinate. So now let's take our distance formula and plug in what we have. So I'm going to write down the formula. So the formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So now let's plug in the x1, y1, x2, y2 values that we have. So looking at x2, that value we have a 6. So I'm going to put 6, and then the x1 value we have is 2. So I'm going to do 6 minus 2, and that's all squared. And then plus y2 is 8 minus y1, which is 3. So 8 minus 3, and that is all squared. So now let's continue with the formula. We're going to use BEDMAS to solve this, so I'm going to do everything in the brackets first. So 6 minus 2 is 4, and that's still going to be squared. And then inside this bracket, 8 minus 3 is 5, and that'll also be squared. So I'm still going to follow BEDMAS. We're going to do those powers next. So we're going to do 4 squared, which is 16, plus 5 squared, which is 25. So we do everything under this big square root symbol. So we're going to add those two together. 16 plus 25 is 41. So the square root of 41 would be the distance. And in Precal, I would accept this as the final answer. Here, I'm just going to make this sign a little smaller. I would accept this as the final answer because you're not allowed a calculator. So I don't expect you to give me the exact decimal answer. The square root of 41 would be perfectly fine. Or if we were to use the estimating square roots skills, we could say, or it's approximately equal to, I don't know, 6.4. That could be the distance in between the two. But I will accept this exact answer over here. So on a test, give me that exact answer. So next, let's move on to example 2. Classify this triangle as scalene, equilateral, or isosceles. So let's just do a little refresher. Scalene means all sides are different lengths. Equilateral means they're all equal. And isosceles means that 2 are equal length. So in order for us to classify this triangle, we need to find all the sides' lengths, or the distance between all of these points. So let's start off with doing A to B. So you might need a little more room for this one. I should have left a little more space on the page, but I'm going to do A, which is 4, 6, to B, which is 6, 1. So I always like writing down the points like this because I like labeling them x1, y1, and x2, y2. So now we're going to use the distance formula. And I'm going to do x2 minus x1, so 6 minus 4. And that's all squared. And then plus y2, which is 1, minus y1, which is 6. And that's all squared. So then we have 6 minus 4, which is 2, so it would be 2 squared, plus 1 minus 6 is minus 5, and that'll be squared. So 2 squared is 4, and negative 5 times negative 5 would be positive 25. So if we continue this, we're going to have the distance is the square root of, well, 4 plus 25 is 29. So that would be the final answer from A to B. Now let's do from B to C. So again, just so I can label the points, I'm going to put B, which is 6, 1, to C, which is 1, 3. Now it doesn't matter the order that you put these points. It doesn't matter which one's x1 and x2. You will get the same answer either way. So here I'm just going to say that this first one is x1, y1, and then this one is x2, y2. So if we're doing the distance, it'll equal x2 minus x1, so that's going to be 1 minus 6, and then squared, plus y2, which is 3, minus y1, which is 1, squared. So 1 minus 6 is minus 5, and that'll be squared. And then plus 3 minus 1 is 2, and then that'll be squared. So minus 5 squared, well, that's minus 5 times minus 5, which is 25. And then plus 2 squared is 4. So there we have the square root of 29 again as the final answer. So right now we have two sides that are the same. Let's see if we can get a third. So we're going to do this final side. So I'm going to say A, which is 4, 6, to C, which is 1, 3. And I'm going to label these points x1, y1, x2, y2. So then we have our distance formula, square root, and we're going to do x2 minus x1, so 1 minus 4 squared, and then plus y2 is 3 minus y1 is 6 squared. So 1 minus 4, that is minus 3, and that'll all be squared. And then plus 3 minus 6 is minus 3 again, which is squared. So minus 3 times minus 3 would give us positive 9. And then again, minus 3 times minus 3 is positive 9. So we're going to have 9 plus 9. So our final answer is the root of 18. So there's the three lengths, and here we can actually label them. This one's the root of 18. We have the root of 29. Oops. And then finally the root of 29. So if we look at all of our names of those three types of triangles, we have two sides are the same and one is different. Therefore, it is an isosceles triangle. And we'll say it's because two sides are the same length. So that is how you find the distance between 2 points. Now let's look at how to find the midpoint between 2 points. So for this formula, we're going to be finding a coordinate of the midpoint. So we're going to be finding an x and y coordinate of the midpoint. That's why when we're looking at this formula, which is here, we have midpoint, and then we have this first part would give us the x value, this here, and then we have a comma, and then this part would give us the y value. So let's find the midpoint of this segment joining -7, 1 and -2, 5. So just like with all of these questions, I like to label x1, y1, and x2, y2. Because then it's a lot easier for us to plug it into our formula. So I'm going to take the formula, the midpoint, and then here's the coordinates. It'll be x1 plus x2 over 2, or divided by 2, and then comma, y1 plus y2 divided by 2. So now let's plug in what we have. So that's going to equal the midpoint, and let's plug in x1 and x2. So that would be minus 7 plus minus 2 divided by 2, and then comma, and then our y1 is 1 plus y2 is 5, and then that's divided by 2. So I'm just going to bring this up here. So our midpoint is going to be, well, minus 7 plus minus 2. Well, if we have a plus and a minus next to each other, that's the same thing as just minusing. So it's like minus 7 minus 2, which is minus 9, and then divided by 2, and then comma, 1 plus 5 is 6, and then divided by 2. And then we could see if we could simplify this anymore, if we could simplify those fractions. So negative 9 over 2, you could write that as a decimal if you want, which would be negative 4.5, but I would also accept if you just kept it as a fraction. So I'm going to keep mine as a fraction, negative 9 over 2. But then 6 divided by 2, that simplifies to just a 3. So the midpoint of this line would be at negative 9 over 2, or negative 4.5, and then 3. So here you can write that, or the midpoint is negative 4.53. Either of those answers I would accept. So now in example 4, we need to do the length of this line segment as well as the midpoint. So we're going to use both the formulas we learned today. So I'm just going to zoom in and start by labeling them x1, y1, and x2, y2. So now let's determine the length of AB. So that would be the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. So we're going to plug in what we have, x2 and x1. So x2 we have 9, and then it'll be minus. Now be careful because the x1 value is negative 3. So we're actually going to have 9 minus 3 squared, and then plus y2 is 1 minus y1 is 6 squared. So remember, if we have two minus signs right next to each other, that's the same thing as adding. So we're going to actually have 9 plus 3, which is 12, so 12 squared, plus 1 minus 6 is minus 5 squared. I'm going to bring this up here. So we have 12 squared is 144, and then plus negative 5 squared is positive 25, because negative 5 times negative 5 is positive 25. So then our final answer for the distance is going to be the square root of 144 plus 25 is 169, or we can actually take the square root of that number because it's a perfect square. So the distance is equal to 13. That would be the distance. And now if we're doing the midpoint, we're going to write down our midpoint formula, x1 plus x2 over 2, and then comma, y1 plus y2 over 2, or divided by 2. So let's plug in the values. I'll scroll up so we can see them. So the midpoint's going to be x1 plus x2, so it'd be negative 3 plus 9 divided by 2, and then y1 is 6 plus y2 is 1 divided by 2. So if we continue, we're going to have negative 3 plus 9 is 6 divided by 2, and then 6 plus 1 is 7 divided by 2. So our final answer for this one, and you could have one or the other, you can either have, well, 6 divided by 2 is 3, and then 7 divided by 2 you can keep as a fraction, or you could write 3 and 3.5, because 7 divided by 2 is 3.5. So either of these would be a good answer. And then we're going to skip C for this one because we haven't learned that yet. We'll learn that in the next unit.